Hello friends, in this video I'd like to solve the following problem from the Vietnamese Mathematical Olympiad 2001, problem number 5. We wish to find all continuous functions f from the interval from -1 to 1 into the set of real numbers such that the following condition is satisfied. 1 minus x squared times f of 2x over 1 plus x squared equals 1 plus x squared quantity squared f of x for all real numbers x between -1 and 1. So it's a very nice problem. Here are my hints. Here's how I suggest to do it. First, use hyperbolic functions. If you don't know about them, they are functions closely related to trigonometric functions. And namely, we have 6 hyperbolic functions, but we will use only 3 of them. Namely, hyperbolic cosine is defined as e to the power of t plus e to the power minus t over 2. Hyperbolic sine is defined as e to the power of t minus e to the power minus t over 2. And finally, hyperbolic tangent is just the ratio of sinh hyperbolic sine and cosh hyperbolic cosine. Many identities are satisfied by hyperbolic functions, and many of them look almost either the same or almost the same as identities for trigonometric functions. For example, we will use 3 identities. Hyperbolic cosine squared of t plus hyperbolic sine squared of t equals hyperbolic cosine of 2 times t. Hyperbolic cosine squared of t minus hyperbolic sine squared of t equals 1. And finally, we have a formula for hyperbolic tangent of double the angle, double the argument. We are not talking about angles here. 2 times hyperbolic tangent of t over 1 plus hyperbolic tangent squared of t equals hyperbolic tangent of 2 times t. You can really easily verify all of these identities by looking at the definitions of our functions. Finally, hyperbolic tangent will be of particular interest because it goes from the set of real numbers onto the interval from -1 and 1, and it's a bijection. And after dealing with it, so I suggest that you substitute x to be hyperbolic tangent of x, of t, let's say. So maybe I will write one more hint for you. So put x to be hyperbolic tangent of t, where t is really any real number. Since the f is continuous, we know the following, that limit as t goes to 0 of f of t equals f of 0. We can take our limit inside. And finally, if you get some result, try to simplify your result as much as possible. And so give this problem a try, and I will see you in just a minute. Okay, so here is my problem. Here is my solution, rather. As I suggested, let x be equal hyperbolic tangent of t for any real number t. We know that it's properly given because the range of hyperbolic tangent is in fact open interval from -1 to 1. You can verify the graph if you wish. And now let's put everything in our functional equation. Our functional equation is equivalent to the following. Okay, and now it's time for some simplifications. First of all, my first parenthesis can be written because hyperbolic tangent is just hyperbolic sine over hyperbolic cosine. So we can write it in the following manner. One is hyperbolic cosine squared over hyperbolic cosine squared. Here we have sinh squared. Here we have, let's leave it as it is for now. And on the right hand side, we have, well, cosine, hyperbolic cosine squared plus hyperbolic sine squared over hyperbolic cosine squared. Very well. F of hyperbolic tangent. And now it's time for various identities. As I suggested, this part right here is just one. This part, this numerator, can be simplified to hyperbolic cosine of 2 times t. And finally, and most importantly, this entire fraction simplifies just to hyperbolic tangent of 2 times t. Moreover, one more thing can be done. I can multiply both sides by hyperbolic cosine to the 4th power of t to get rid of my denominators. And now I get the following. Hyperbolic cosine squared of t times f of hyperbolic tangent of 2 times t equals hyperbolic cosine squared of 2 times t times f of hyperbolic tangent of t. Well, and I will write it in this way. After division, I have the following. Okay. So in fact, my functional equation is equivalent to this. Notice also that division or multiplication by cosine, hyperbolic cosine, is illegal because hyperbolic cosine is always positive number. Okay, very well. And now I suggest that we define a new function. So let's say g of t equals f of hyperbolic tangent t over hyperbolic cosine squared of t for real numbers t. Notice that since f is continuous and hyperbolic cosine and hyperbolic tangent are also continuous, we know that g is continuous as well. G is continuous. Okay, but now let's notice I will mark this equation star. Star becomes what exactly? Well, if you take a look, I can write it in the following way. G of t equals g of t over 2 for every t. Yes, I have changed t to t over 2. So instead of 2t, I have 1t, and on the right hand side, instead of t, I have t over 2. But that holds for every real number, t. So that can be written as g of t over 4, g of t over 8, and so on and so on. And finally, so in other words, for every real number t and for every positive integer n, g of t equals g of t over 2 to the power of n. And now it's time to use the continuity. Let's take a limit. Taking n to infinity, we have the following. G of t, the very same g of t, equals equals what exactly? Equals limit as n goes to infinity g of t over 2 to the power of n, and now by continuity it can be written as that. And notice that for any fixed t, this number is just 0, so it's g of 0. And g of 0, what is g of 0? Well, g of 0, if we go back, it's f of hyperbolic tangent of 0 over hyperbolic cosine squared of 0. So it's just f of 0 over hyperbolic cosine of 0. It's easy to verify, it's just 1, so it's just f of 0. It's just f of 0. Very well. And one more thing, remember that g of t, what is g of t? Well, g of t was defined as f of hyperbolic tangent t over hyperbolic cosine squared of t, and that holds for every real number t. That means that f of hyperbolic tangent of t equals f of 0, which is some constant, let's say it's c times hyperbolic cosine squared of t, where c is a constant. Okay, I need another page. Perfect, I have my page. So, and now I wish to simplify my function. I wish to simplify it. How can I do it? Well, let's take a look. Hyperbolic tangent is e to the power of t plus e to the power, minus e to the power minus t over e to the power of t plus e to the power minus t equals c times hyperbolic cosine is e to the power of t plus e to the power minus t over 2 squared. It's by definition. And now I wish to go back to my x's. I wish to go back to my x because this number is just x, and I wish to express the right hand side in terms of x. How can I do it? Well, x equals e to the power of t minus e to the power minus t, e to the power of t plus e to the power minus t. And now what I will do, I will treat it as an equation and I will solve for t. X times e to the power of t plus x to the power x times e to the power minus t equals e to the power of t minus e to the power minus t. And now I will multiply both sides by e to the power of t, and I have x e to the power 2 times t plus x minus e to the power 2t plus 1 equals 0. And now, you know what, I will leave x plus 1 on the left hand side, and I will put everything else on the right hand side. So I have 1 minus x e to the power 2 times t. So 1 plus x, 1 minus x equals e to the power 2 times t. Very well. And that means that e to the power of t equals square root of 1 plus x, 1 minus x. Is it right? Yes, it is. Very well. So here is my formula for e to the power of t. Let's also notice that e to the power minus t is just its inverse. So I can express e to the power of t plus e to the power of minus t. In this way, it's 1 plus x, 1 minus x, plus square root of 1 minus x over 1 plus x. Well, after making a single denominator, if the denominator will have 1 minus x, 1 plus x, and here I will have 1 plus x squared under square root plus 1 minus x under square root. And that's what exactly? Well, that's 1 plus x plus 1 minus x over 1 minus x squared. So it's 2 over square root of 1 minus x squared. And that means, in turn, that means that hyperbolic cosine squared of t, which is just e to the power of t plus e to the power minus t over 2 squared, what is it? Well, it's just 1 over 1 minus x squared. So now we have our simplified form of our function f. So let's maybe, you know what, I will mark this condition triangle, and triangle becomes the following: f of x equals c over 1 minus x squared for x's between minus 1 and 1. Okay, very well. And now we should verify our result. Verification. Or, you know what? We can very easily do verification, but let's also notice then we can skip it. Why? Because we know that our initial functional equation was equivalent to this equation which I marked star. And it should be pretty easy to verify this condition. But you know what? Whatever, I will verify the very first equation. So I will take my very first equation and I will plug in my function which I got. Okay, so let's do verification. 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 Left hand side. On the left hand side we have 1 minus x squared, f of 2x, 1 plus x squared. And let's put it. Well, 1 minus x squared, c over 1 minus 2x, 1 plus x squared. After some simplification, it will be 1 minus x squared, c 1 plus x squared. And in the denominator we have 1 plus x squared minus 4x squared. So it's c 1 minus x squared, 1 plus x squared. And in the denominator we have 1 minus 2x plus x squared, 1 plus 2x plus x squared. And let's simplify something. Notice that 1 minus x squared or 1 plus x squared, this second power can be cancelled with this part. Am I right? No, I'm not. Sorry. Sorry, I'm not right. I can do something else. C 1 minus x 1 plus x, 1 plus x squared over 1 minus x squared, 1 plus x squared. This is correct. I can cancel this with that square, and I can cancel this with that square. So my left hand side, it's really c times 1 plus x squared over 1 minus x squared. What about the right hand side? Well, nothing yet because I have run out of space again. Of course. Now I can do it. Right hand side. On the right hand side, let's go back. We have 1 plus x squared times f of x. That should be easier. 1 plus x squared times c over 1 minus x squared. Well, it's exactly the left hand side. Now we see it clearly. So maybe, you know what, maybe I'll write that it's 1 plus x squared f of x, which is just the right hand side. So, all in all, we have the following solutions. We have the following solutions. F of x equals what exactly? C over 1 minus x squared, where c is any real constant, and obviously x is between -1 and 1. And that closes our problem. That closes my solution. A fairly nice problem, I'd say. We have used hyperbolic functions. We have used many identities. And the rule is, if you look, first of all, you should know by heart trigonometric identities if you are preparing for some type of contest or Olympiad. And if you notice something which looks almost like trigonometric identities, but not quite, it's not the exact trigonometric identity, maybe think about hyperbolic identities. Because, for example, if there were a minus here, that would look like formula for tangent of twice the angle. But we don't have minus, we have plus, so it's hyperbolic tangent of twice the argument, and so on and so on. Hyperbolic functions, I'd say, are underappreciated. They are very nice. They are, if you go into the realm of complex numbers, you very soon realize the close connection between these two types of functions. Anyway, our problem had one family of solutions indexed by real constants, and that's it. Thank you for watching. I wish you a nice day and see you next time. Goodbye.